In this example, we have given the graph of this function y equal to square root of 6x minus x square, right? So the graph of that function is given over here. Look like a kind of a semicircle kind of shape, right? So we have given the graph of that. And our goal here is to use the transformations, right, to create a function whose graph is as shown. And I think that's what it is talking about, this graph over here. So the question here is, we have given this graph on this left hand side of that red curve, right, whose function is square root of 6x minus x squared. By some transformation technique, it says that the graph has been obtained into this way over here on this green curve over here. So our goal is to see if this is how we have transformed the given curve, the red curve, into this green one, then what is the corresponding function, right, corresponding to this green curve. So how can we get that? So what can we do here if only the transformation techniques has been applied? Okay, let's try to see here. So you can see here the left endpoints over here is at the origin of this this curve given over here for the red curve, right? But you can see here that has been kind of a little bit shifted. It looks like 3 units to the right, right? So it's begin over somewhere over here. And that backs up also, you can see the idea over here on the another endpoints here for the curve is at 6, right? So that's what you can see over here. And that has been kind of shifted again, right on the more on the right side, 3 units on the other side. So because it was here at 0, now it's at 3, and then this point was here at 6, now this is at 9. So it looks like definitely the points has been this curve has been shifted 3 units to the right. So that's one of the observation we can see here. And so if that is the case, if it has been shifted 3 units to the right side, right, 3 units to the right side, so how can you get the function corresponding to that from the given one? So how the horizontal, so you can see clearly here it's a horizontal translation, right, towards the right side. So how can we do that? How can we do the horizontal translation? If we subtract how many units you want to move how many units you want to move on the right side, we want to subtract that many units on the x variable over here. So something like if y equal to f of x is the given curve, then what you just need to do is, if we do let's say f of x minus 3, if we evaluate that means if you replace x by x minus 3, then that will give you the curve which is shifted 3 units on the right side. So if that is the case, if the given function is here y equal to 6 square root of 6x minus x square, then what could be the another equation if we shift only this curve over here, shifted 3 units on the right side? We just need to compute this, right? So if that is the case, y will be equal to square root of, right, we just need to replace x here completely by x minus 3. So in that case, this will be 6 times replace x by x minus 3, so that we shift 3 units on the right. Do the same thing over here, again replace x by x minus 3, and then write down in this way. So when we do that, it looks like we have shifted this curve over here, this red one over there, this red curve over here given, we shifted that 3 units to the right side. Okay, but are we done? No, I mean this curve over here, this given curve is not only it is shifted 3 units to the right side, the shape of the curve it doesn't look like similar. What has been done over here? Can you observe that fact? It looks like you can see the red curve over here, it's over here, it is at 3, but the maximum point over there is at right, so over here but this has been the maximum point for this green curve is over here. How is that possible? If it's the same curve, we are just like kind of stretching, shifting, or shrinking, something like that. What can you say about that fact? All right, what might have happened? So if it is the maximum point right now is over here, and it's over here, the height of the curve, if you see over here is at 3, and then over here it is at 6. So if that is the case, probably it has been stretched vertically by a factor of 2, right? So if we trace vertically, and then we will get this green curve from this red one, but by a factor of what? If the height of the curve here is at 3, and then if this is at 6, then by a factor of 2. And how can that be obtained? If we multiply by, we know that if we have y equal to f of x, then if we multiply by just how many, like if some curve is traced vertically by a factor of something, we just need to multiply by that, right? So for example, on this case, if the curve is traced vertically by a factor of 2, then this must be 2 times f of x. So if that is the case, if this curve has been shifted in this way, and then if this has been, you know, is traced vertically by a factor of 2, then we just need to multiply by now 2 to the this shifted curve over here. So 6 times x minus 3 minus square of x minus 3 will give you the function that will describe this curve over here. Do you buy that? Okay, so then if that is the case, then we are done with this problem over here. Now what we just need to do here is, if you want, you can actually do some simplification. Okay, so you can actually, if you want, you can just leave it like that, no problem with this. This is already the given functions which would represent the given curve. But if you want to expand, you can expand what is square of x minus 3, distribute here by 6, right? And then actually come up with another simplification. So if you want to do that, let's try to work. Okay, so what we can do here is 2 is here as it is, right? So let's distribute by 6 over here, so we get 6x minus, right? So 6 times 8 will be, sorry, 6 times 3 will be 18, right? And then minus, and then square of x minus 3, you can multiply by x minus 3 with x minus 3, multiply first term with first term, we get x square, multiply x with negative 3, we get negative 3x, negative 3 times x will be another negative 3x, negative 3 minus 3 will be positive 9, so we get x square minus 6x plus 9, right? So that's what we can get. So we can plug that in over here, that expansion of square of x minus 3, and then we get 2 times square root of 6x minus 18. Now distribute by the negative over here, the sign will be changed, right? So negative x squared plus 6x minus 9, and then you can combine the like term here. So here is negative x squared, let me write that down, positive 6x will be positive 12x, negative 18 minus 9, when we combine we get negative 27, and then that's another simplification. So as I said earlier, so we already have the transformation over here, right? So this is already a good answer, I assume, but depending on what are you trying to do, if you want to simplify these or further or something like that, then if you definitely you can continue like this. All right.